Hello everyone. In this video, we will wrap up our exploration of topic 12.1, the interaction of matter with radiation. And in particular, we will return for one final conceptual look at the Schrodinger model of the atom. All right, so our final sort of most advanced model of the atom, and in particular the model of the hydrogen atom, is one that actually is often taught in one form or another in even high school chemistry, okay? And that is the idea of the electron in what are known in chemistry as orbitals, okay? But we can now identify the orbitals as the wave function that solves the standing waves and Schrodinger equation for the hydrogen atom in three-dimensional space. So what these are the solutions, like our two-dimensional standing waves in the Bohr model of the atom, to the wave function for the electron at different energies in arrangement around that central proton. And it's pretty complex mathematics. It's pretty nasty, actually, although not more advanced than a first-year quantum mechanics student would be able to handle in undergrad. But the result are these orbitals. And the orbitals are probability density graphs for finding the electron in a particular place. And they have these shapes. They correspond to the S, P, D, and F blocks, and have shapes governed by the Schrodinger equation. You'll recognize this in part as at least related to the Schrodinger equation that I wrote very early on. This is the formula for the energy levels of those particular wave functions. And here's the wave function itself. It's written in spherical coordinates, r, theta, and phi, rather than x, y, and z. But this is the solution to the wave function that corresponds to this particular energy level. And these shapes, these orbitals, are the logical outcome of applying this wave function model to the proton. And it's why, when asked what is an orbital exactly, usually how it's explained, particularly in introductory chemistry, is sort of a region where you would find the electron. A second order correction to that is, well, it tells you the probability of finding an electron at any particular point. But in truth, what you're actually graphing is sort of the wave function itself. And as a result, if you square the wave function in space, you get these probability density clouds for finding an electron at a particular point. But our sort of considered understanding of what that wave function really is that really is the electron in some important sense. And so when these orbitals are sort of placed on top of each other, or an electron is sort of transferring from energy level to energy level, they're not really sort of popping over from this energy level to this one. The wave function itself changes state when it goes from one energy level to another, and the wave function really does correspond to the electron itself. So anyway, this is beyond the scope of this course, but I thought it made for a nice wrap-up of what that wave function is good for and how it is ultimately connected to these things you may have examined in chemistry, that is, these orbitals where you are likely to find an electron.